Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our online lectures on engineering drawing and computer graphics provided by NPTEL. In today's class, we will learn how to use some of the Solidworks command to construct 3D geometries. In today's class, mainly we will construct a cylinder, a tube and a hat. How to construct these things using Solidworks. Thereafter, we will go with assembly drawings, constructing something named a shaft and disc arrangement, and other one is a rectangular bar fit in a square hole. How to assemble these things, we will see it. So, after double clicking our Solidworks, opening a new part drawing, we will have this white blank screen. In this, we use a revolve command to construct 3-dimensional cylinder. The first one is, we always begin either with front plane, top plane or right plane. So, front plane click, normal to front plane we go. Cylinder we would like to construct. So, in the sketch mode, go to a circle, locate some point and change its radius to 25 units. Go to features, extrude boss, go to 50 units, click OK and then OK. This is one way of constructing cylinders by using extrude boss base. One can also construct using a revolve command. For example, if I have a center line, if I can construct a rectangle, rotating that rectangle by 360 degrees also, we will be in a position to construct a cylinder, and that is the thing what we will see. So, a new one, part, OK, go to front plane, normal to it. In the sketch mode, first of all draw a center line. Once it is done, we would like to revolve a cylinder. So, for that purpose, I am drawing a line, perhaps using smart dimensions, so that I will have a better control on radius. 25 units of length I will draw, then extend it from there to there, use smart dimensions, make it 75 units, then again construct a line, goes there. So, for revolve command we always require closed objects. So, once it is done, use control button, hold that line, similarly click the other line by keeping control button, control, hold and line. Now, go to features, revolve boss base. Around this axis we would like to have, which is automatically selected as line 1, because the first line what we have constructed is that center line. So, it is automatically selected. If that is not the case, we go click that line, then it will be selected there, then click OK. This is another way of constructing cylinder. Now, using this revolve, we can construct axisymmetric geometries. Let us begin it in this way. Now a new one, click part, OK. Now go to front plane. Now we will construct a axis symmetric object. Line, first of all a center line. This is always be the first line. OK. Now construct another line. Because we would like to have a hollow cylinder tube. Construct that. So, a center line we have constructed and a rectangular patch. Now, use control button, click, select this one also, select this one, select this one. Now, go to features, click revolve boss base about that center line. Now, click OK. So, we have that hollow cylinder. If we are interested in stepped cylinder, what we have to do? If you are not interested in saving geometries, do not save, click OK, do not save. Now, open a new one. We would like to construct a stepped cylinder using revolve. So, click part, OK, go to sketch. The first step is always be center line on a front plane, normal to it, from there to there, draw. It is a stepped cylinder. That means, we have to construct a line, goes down, from there again goes down, click OK, then from there join this one. So, this entire object is done. Now, go to features, revolve boss base, it is revolving around this center one. That is the thing what we can see, axis of revolution as this line 1. If we are interested about 360 degrees, we go with 360 degrees. No, we are interested only 270 degrees, we click 270, OK, then click OK. So, when we revolve, because it is 270 degrees thing, we see this object. Now, let us look at isometric view. To visualize isometric view, what we have to do? Go here, click that one. Any other view like diametric view, trimetric view, it will be in that way. Now, if we are interested about seeing different orthographic views, here we have different things, something like single view, 2 view horizontal, 2 view vertical and 4 view. Let us click this 4 view. What we can see is something like front view here, top view here, from left side, from right side to left side, if you are seeing left side view, what we are seeing there, and what about the trimetric view. So, all the pictures at a time we can get as different views. Now, if we want to go back, what we have to do? Go there, click the single one. In that single one also, we are more interested about isometric view, then click that. This is the way a revolved thing we will construct. Now, a stepped hollow cylinder, if we are going to construct, the procedure is go to new file, part, OK. Now, sketch a center on a plane, front plane, go there. Now, click a center line, is supposed to be hollow. So, what I will do is click 1, I will not construct a complete sketch, but something like a lines only we will construct, see what will happen. So, it is not a complete sketch, only lines I have constructed, not a closed one. Now, what I will do? I will select this entire one, go to features, try to revolve boss base, then it says because it is not a closed sketch, the sketch is currently open. A non-thin revolution feature requires a closed sketch. If you want to give solid visualization and so on, you have to really give the thickness. Would you like to sketch to be automatically closed? Let us try that. What will happen? If I click S, the profile could not be closed without creating self-intersecting OK. Then it picks automatic dimensions where 10 mm you can really give it something like 0.5 mm also. A very thin shell one will be in a position to construct something like a tube. So, if you are not giving any closed entities, it try to have this backend program which automatically assumes certain dimensions, try to construct this. So, this kind of ducts where the thickness is very small compared to other dimensions can also be possible. So, if you want to really close this one, something like a can, water can kind of thing, what we have to do is perhaps pick this circle, on that again extrude the portion and fill it. So, let us try that. So, let us go to top plane, especially normal to this plane, let us go there. Now, go to sketch, we have to carefully select this thing. Okay. Now, we draw a circle. Let us see. Of the same dimensions. Once it is done, we go with extrude boss base, see in which direction we would like to have. So, it should be in the reverse direction, and what we would like to have is close the object, something like some 50 mm, maybe something like 70 mm. Click OK. So, the solid object will be completely filled. Now, if I would like to really construct only hollow can, what we have to do is first create a circle, give something like a cylindrical portion up to certain level of thickness. After that, construct a rectangular one and rotate it. Let us do that with another example. So, what we are going to do is a closed cylinder, if we want to construct in a stepped way can style. Let us try that. A sketch on the front plane, normal to it, a center line, we would like to have a can style kind of thing. So, what we will do is pick a line from somewhere of certain mouth, it goes there all the way down end. Now, it is not a closed one. So, control pick this one, this one, this one and also this one. Go to features, revolve boss base, because thickness we did not mention, it is not a closed one. (360°). Oh, something has happened wrong. Go to front plane. Now, a small thickness, let us give it. In this case, offset is the best option to really go with. So, now it is a complete one. Select this one, go to features, revolve boss base, click OK. So, if you are seeing on other side it is closed, inside it is a hollow one. Now, let us look at a cut sectional view of this entire can. You see the cut sectional view, a hollow can. This is the way you construct the objects. If I would like to construct a converging diverging kind of nozzles, typically in engineering we see nozzles. These nozzles always be to accelerate the flow from one location to other location. If you want to increase the speed, you use these nozzles. So, how to construct it, a typical rough sketch we are going to see. The typical nozzles have one particular kind of functional relations. They can be converging, they can be diverging, they can be both converging, diverging kind of nozzles. If you are seeing rocket engines, on back side wherever the exhaust gases are coming out, such kind of thing what we call these nozzles. And one of the simple way of constructing these nozzles is, first draw a center line, then use a spline, the easiest construction what we are going to do. That portion is converging and that portion we are having diverging. So, this one I would like to really revolve around that with a hollow gap. So, for that purpose, if we would like to have a hollow gap, what I have to do? Pick this one, first construct an offset, not in this direction, but in the reverse direction. We do not really require that thickness, maybe 1 mm thickness is good enough, like a tube, then click OK. Now, zoom into this portion, add lines, perhaps we would like to have a very vertical line from there to there, done. Similarly, zoom into this portion, join by lines there to there. Now, we have a complete closed picture. Now, press escape, select this entire thing, go to features, revolve, around that we have this particular shape. Based on the engineering designs and numbers, the technical drawing, one has to construct it. Let us look at different views of this nozzle. So, for that purpose what we have to do, first of all keep it in isometric view, then go there, look at these different views. So, something like front view, top view, side view and isometric view we will get. Now, we will go with assembly drawings. So, for example, if we have to do assembly drawings, first of all what we have to do is construct different parts and then join them together. For example, I have something like a cylinder on which there is a circular disc. I would like to really mount it, and it is supposed to be fixed at one end. How to do that? So, for that purpose what we do is, as usual, first we have to construct different parts. One is cylinder shaft, other one is circular disc, and we would like to really mate them together. So, to do that, the first one is go to sketch, frontal plane, construct a cylinder. First a circle we are going to construct. This circle dimension supposed to be correct 20 mm in diameter. Go to features, extrude boss base, it may be some 100 mm or 100 units, then click OK. So, we have this cylinder. Now, what we have to do? Save this one as an object. So, go there, save as, give something like part 1A, save. So, cylinder is done. Now, open a new one, again part drawing, click OK, go to frontal plane. We would like to have a circular disc. So, circle, go there, construct. This circular disc what we are going to construct, it is going to mount on this cylinder. The outside diameter of this cylinder is 20 mm. In that case, our disc what we are going to construct, inside of that portion supposed to be 20 mm. So, let us go smart dimensions, pick this one, inside supposed to be 20 mm, done, but it is a circular disc. So, a circular disc means again we pick a circle, go there, maybe it might be of smart dimensions 45 units, done. Now, we would like to make a circular disc. So, go to features, select these two things by control object, go to extrude boss base, we have a cylindrical disc, done. Now, save it as, save as part 1B at the same location. So, we have constructed two parts. What we have to do now, we would like to really make these two parts so that one single assembly one can really get. For that purpose, what we have to do? Click this new. Now, go for assembly, because parts we have already constructed. Now, we are going to construct an assembly. Click OK. Now, when you do that, either it will automatically select the parts whatever we have constructed in a specific directory. Otherwise, we have to click browse, pick those parts which we are interested in. Part 1, control part 2, open. Then it will automatically show. Now, leave them by click 1. Similarly, leave them by click 2. So, both the parts are brought together in a single assembly drawing. Now, this one has to be mounted on that. For that purpose, what we have to do? These two things you can really move it whatever the desired location you would like to have in that way. But these are not fixed on the cylinder, they are freely moving. For assembly drawing, what we have to do is made these objects. For that purpose, what we have to do? There is something like made command, click this one. Now, this surface and internal surface, they are supposed to mate each other. For that purpose, what we have to do? Here you can see concentric mate. So, click that and OK. Once you are done, this object can move concentrically out of that only, but you can't really move this circular disc away parallel to this in this direction. So, even if you are trying to move that one, this one goes only in the concentric way, it can't go anywhere. Now, we want to really fix this entire thing, lock it from here to one of the end. For example, I want to keep it to this end. To do that, what we have to do? After clicking OK, now again click mate command, pick one of the surface. So, for that purpose, we can really rotate this surface and this surface control by holding this control. Let us do it once again. So, this is the object. Now, this surface, whatever this on the circular disc and this surface supposed to be together. To do that, what we have to do? Click mate, pick this surface. Once you select that surface, it will be highlighted. Then go to this surface, click. These two things are coincident. So, once this coincident is done, click OK. Now, you have that object. Now, even if you want to really move it, they won't move out of that object. Now, if you click OK, it will be assembled. So, I can't really move it. Now, I don't want to really lock it here, but I want to lock it on the other side. For that purpose, what we have to do? Let us just redo that. For that, first of all, I am undoing it, so that this object can be easily moving. What I would like to do is, this surface and this surface supposed to be coincident. For that purpose, what we have to do? Click OK. The surface, let us undo. So, click mate, pick that surface, control, pick this surface, then OK. This is the way we can create that object. Now, we would like to have one more disk here. We do not have to reconstruct one more thing. For that purpose, what we can do is, we can again insert one more component, perhaps part B. Done. So, now I would like to really mate these surfaces. What we have to do? Click OK, mate this surface and internal of this surface we will like to mate. So, this one can move on this object. Now, what I want to do is, this one supposed to be locked on that. For that purpose, what we are going to do? Mate this surface and this surface coincident. This is the way we create that assembly drawing. Now, I would like to have something like tangent to this surface, rolling on that surface only I would like to have. For that purpose, what we have to do? Perhaps again insert part B, pick this one. So, this is the object what we have. Now, I would like to really make this surface tangent to something like a cylinder. This is the cylinder, but tangent only I would like to have. Click OK. So, this object always be, I can really move anywhere, but it always be tangent to that surface. Whatever I do, it always be tangent to that surface, we will have it. Now, I want to really lock this surface with this surface, they should touch each other. For that purpose, what we have to do? Once after clicking that, mate this surface and this surface, you see they are coincident kind of surface, that is the reason it is picked this one. Now click OK. Once it is done, if you want to really move this object, it touches that surface and tangential to that surface only it rotates. This is the way we construct a simple assembly drawing. In the next class, we will know about how to make pipes, hollow pipes, how to make threads over these pipes. See you in the next class. Thank you.